So if you recall me saying last week that messaging is a pattern that allows many-to-one communication, signaling is a type-safe way to do the opposite of that, which is one-to-many communication. So this would be analogous. So signals are very analogous to JavaScript events, except that they don't bubble up a hierarchy like JavaScript events do. There's a reason for that. So JavaScript events are tied to a DOM node, and a DOM node has an inherent hierarchy with it. Signals are not tied to DOM nodes. You can define a signal pretty much anywhere that you want, and it behaves like a JavaScript event that doesn't, like I said, that doesn't bubble. So any number of people can subscribe to a signal with a callback that we call a slot. So anybody that's used Qt before, this verbiage is stolen directly from Qt. So Qt has signals and slots. They do the exact same thing. So in this case, we've got a signal which is defined as an interface object. And the reason for that is so that you can, when you create a signal as the let's say your class or whatever, the code that you write that defines signals can expose that signal as an interface, which is more or less an immutable interface. There's only connect and disconnect. There's no method on here for actually emitting the signal, because the person that creates the signal is responsible for emitting the signal, not other consumers of the signal. So if all I did was expose this signal class, which has an emit method on it, then any third party could come along and emit your signal for you, which you don't want. So very common pattern that we use all over Phosphor and Jupyter Lab is that you'll define your signals as private attributes on your class, and then expose an iSignal object as a read-only getter. So that way the people that are consuming your signals, all they can do is connect to them and disconnect from them. They can't actually emit them for you. And again, you're connecting slots, which are just functions. First argument is the object which emitted the signal. So this is known as the sender of the signal. And the second argument is the arguments that are passed with the signal and those. So those are templated on types T and U, which is actually defined by the signal. What would have been nice is, rather than limiting this to one argument, is providing up to n arguments. The problem with that is that TypeScript doesn't allow you to have a variadic number of generic arguments. So it would be, basically we would end up having like a bunch of redefined types, like slot 1 with 1 argument, slot 2 with 2 arguments, slot 3 with 3 arguments. It gets really kind of a pain in the butt to deal with. So rather than go through all of that drudgery, I've just defined it as a single slot. And if you need to pass, quote unquote, more than one argument to your slots, you just define an object which has all of those types and all of those things, so like an options object or something like that. So that's the reason you only have one argument object. It would be better if we had more flexibility in the TypeScript language, but we don't. And as far as I know, even on the current versions with TypeScript 3, this is still not possible. It may be possible with pure functions, but it's not possible with classes. And since the iSignal object would require variadic generic arguments, it's still not possible. So this is where we are. So yeah, so this is a pretty well documented file. It's one of the first things that we ever wrote in Phosphor. Basically, going from the bottom up also is pretty much the order in which the packages were written. So this is extremely well documented. There should be examples of stuff of how to use these actually in the documentation, so I don't really need to go over that. But it's a very simple class. So you instantiate it. Typically, you're going to pass this as the sender, again, because the sender is the object that's emitting the signal. If we were in Python and we had a descriptor protocol, talking in the sender would not be necessary, because we could capture the sender as the signal is accessed. But that doesn't exist in JavaScript, so we have to provide it explicitly when you construct a signal. And then you've got your connect and disconnect methods, and then your emit method. So when you own the signal, you can actually emit the signal. Now, when you actually do an emit, this is similar to, or analogous to sending a message on the messaging package. All of your subscribers or all of your slots that are connected to that signal, they're invoked immediately. So just like sending a message, whereas if you post a message to a message handler, it's delivered asynchronously. Emitting a signal, all the slots are invoked synchronously. But in the same way as sending a message, you don't expect the emit method to throw, because it's kind of like you're emitting this thing out into the void, and you don't care who is listening in the same way you don't care who misbehaves. So any exceptions that are thrown by any of your slots in processing that signal will be caught and logged to the console. By default, there's also a way to install your own global exception handler for that in the same way we do with the messaging package. So people that basically your code, when it's emitting a signal, you don't have to worry about that ever throwing in exceptions. It's always safe to emit. There's also a few extra static functions defined in the signal namespace that allow you to control on a more granular, maybe not on a more granular level. The most granular level to disconnect a signal is actually get the signal and call disconnect. But if you need to remove all of the connections between a given sender and a given receiver, or disconnect a sender entirely or disconnect a receiver entirely, that's possible. So when you actually make a connection between a sender and a receiver, the receiver being either the slot function itself or the instance, the object which owns a method that you're connecting as a slot. If you need to disconnect an object entirely, that's possible with these static functions. The one that we use most often is probably this clear data function, which clears all data associated with an object. So we use this when in the destructure method or the destroy method, or the dispose method, sorry, the dispose method of widgets. So when you dispose a widget in the very, very base widget class in its dispose method, it calls signal.clearData on itself. And what that will remove is it will remove all the connections for all of the methods that you have installed as slots. It will clear all the connections for the signals it has defined on itself, and it will interrupt any pending signal emissions either to or from that object. So let's say some weird thing happens and some object is actually responding to a signal being emitted, and in response to that, it disposes your widget. Even though you're already on the path of that signal being emitted, that widget gets disposed, nothing else happens to that widget. So all of those connections are severed immediately, and it's not going to get any more notifications. So it behaves well in that way. And that's all done under the covers by using weak maps keyed on both the senders and the receivers. So you don't technically have to call disconnect all or clear data when your object falls out of reach from the garbage collector. It will all be collected, and all of those connection objects will automatically be garbage collected. So it's not necessarily required, but if you're not absolutely sure that your object is falling out of the scope of the garbage collector, you can go ahead and call clear data to make sure it happens properly. And then again, like I said, you can install and see what the current exception handler is. So it's a very simplistic module, but it's useful for lots of things. Just like the JavaScript event pattern is useful for lots of things. There's actually an analogous module in Node, which is a Node package that's basically used all over the place at the bottom of everybody's dependency hierarchy. It's called Event Emitter. It behaves very similar to Phosphorus signal package. The exception being the Node package is not type safe because it's not written in TypeScript, and it's also far less functional than Phosphorus is. So you can you subscribe to in the Node package. You subscribe to event names, which are strings, and so that can be anything. It's very easy to misspell things. There's no ability to misspell anything here with this package because you're not dealing with strings. You're dealing with actual real objects. The Node package doesn't have any concept of disconnect between or disconnect just a sender or just a receiver or anything like that. You can disconnect from a signal in the Node package on a very singular, or disconnect from an event on a very granular event level. However, if you're on the path of that event already being emitted and you disconnect from it, you will still receive the event. So in my opinion, that's a logic bug on the Node package, but it's frozen, so it's never going to be fixed. So we don't have that problem in the Phosphor package. But like I said, pretty simple package, but a very important pattern that we use all over the place.
Yeah, Chris, could you talk about the differences between this and, or maybe differences between this and the messaging package?
Yes, who is that asking? Was that Ryan?
It's Ryan.
Yeah, so again, they're basically inverse patterns of each other. The messaging is a many-to-one pattern. So you have many people or many objects wanting to create messages and send them to a single consumer, which would be the message handler. With a signal, you have one producer, which is the thing that owns the signal, and it wants to broadcast that to many consumers. So one's a fan in and the other's a fan out. Does that make sense?
Yep, I think that answers it. Thank you.
I think we'll go to disposable next. It's another pretty low-level independent concept. So you're going to see this all over the place in Phosphor and JupyterLab, this iDisposable object. It's a very simple interface. If anybody's ever used C#, they have a iDisposable interface just the same way. They don't have a Boolean flag that tells you whether the object is disposed or not, but they do have a dispose method. So C#, just like JavaScript, doesn't have destructors like you would get in a same language like C++. I'm not showing my bias here at all, but basically there's always going to be a need, whether you have a garbage collector or not, to clean up resources that you own when you're done with an object. And you see this in Python. You see people abusing the under del method for this all the time, or somebody's written a pattern like this where you have a destroy or a dispose method. And basically what that means is that, hey, I'm done with this object, but it may have this whole tree of resources or a file handler or something else that it needs to make sure that it closes or disposes of, so that the garbage collector can do its job and the application can continue functioning normally, and we don't have any sorts of resource leaks. So in C#, this is called the disposable pattern, or iDisposable. We have the same thing. And basically all it is an object that has a method called dispose. And when you call it, that object should dispose of itself and dispose of any of the resources that it holds. And the only guarantees that that method provides is that you can call it multiple times and it only does something the first time that it's called, or any calls after the first are guaranteed to be no ops. I've gone ahead and extended that interface a little bit so that you can test to see whether an object has already been disposed or not. It's true if it hasn't been disposed, and once it turns to false, it will never go back to true again, because you can't undispose an object. So this is a very, very simple pattern, but it ends up being very, very robust, because then you can create things like, hey, here's a disposable delegate, which is just a class that wraps up a function that when you dispose this object, it will call this function on dispose. So that now you can basically have a function that does some cleanup for your module or anything like that, throw it into a set of things that are going to be disposed when you're done with your module, and your cleanup function is going to be called once and exactly only once. Or you can create a disposable set, which itself is disposable. So this allows you, let's say you've got, you want to keep track of a bunch of things that need to be disposed when your own object is disposed. Well, you can just create a disposable set, add a bunch of stuff to it, and then dispose it once, and it will make sure that all of its items are disposed exactly once and only once. So you'll see this all over the place. All of the widgets in Phosphor are disposable. Most of the stuff in JupyterLab is disposable. It doesn't have to be, it can be any JavaScript object can implement the disposable pattern, and then you can dispose things. Again, it looks very simple on the surface, but when you start actually seeing it in action, it becomes a very, very nice and clean way to track resources throughout your application and make sure they're handled or cleaned up with appropriately. Any questions on that?
Yeah, so there are a few spots in JupyterLab where we've done this. We've adopted adding a disposed signal the way you do on PhosphorJS.
Dropping off soon.
And so I was wondering if it's worthwhile in Phosphor maybe to have an additional, like, observable disposable or something like that, that basically defines that disposed function, because I just did a search. There's 3 spots in JupyterLab where we've defined the disposed signal on something, and you've also done it on widget. It seems common enough that sometimes you want to say not only is this thing a disposable, but it also comes with a disposed signal.
I was going to extend that one more and say it would be awesome if there was a convenience class that you could inherit from that had that logic in there.
So 2 answers to that. Number 1, I'm not opposed to adding some additional interface, which adds that signal as a property of the interface, which would obviously, if you say that you implement that, now you're forced to define your own signal. But number 2, I wouldn't want to make it a convenience class because you're very easily going to get into a situation where you have competition for who should be the base class on that. And this is the problem I see with Node's event emitter, because it comes with a class that you have to inherit from. And now you're basically, your base class is inheriting all of that garbage that comes with Node event emitter's internal state. This is why I didn't make some very base root object type, let's call it like a Phosphor object that has, signaling capabilities, messaging capabilities, and all that kind of stuff on the base class, because that would then start forcing people to inherit my base class as their ultimate base class. And so I wouldn't want to do that here either. I'd much prefer it to be an interface that you implement and then just define your own signal as needed.
Yes, I think the signal, I think the interface would be really helpful even without a class, but I think if the disposable delegate and disposable set had that signal, that might be nice too.
So there's a reason I didn't do that, and that's because of the storage overhead that's associated with that signal, and not many people actually using it. Basically, I try to have it as you only pay for what you use.
Yeah, that's fair.
I could definitely make a observable disposable delegate, for example, and we could make derivations of those classes that have those things, but I definitely don't want to add it as the default on those classes just because there is a memory penalty for using them. And
that makes a lot of sense. But yeah, as long as it's in the toolkit, I think that would be good.
Yeah. So if somebody wants to nominate themselves to open an issue, feature request for those things, I can take care of those.
Cool, I'll do it. I don't even mind doing a PR if you prefer that.
That's fine too.
Okay, cool.
I was just going to mention the convenience class I saw as a convenience, not as a must to inherit from. But it sounds like you also don't want to encourage people to use that because, like if there is a convenience class, people are going to assume that they should inherit from it. Is that your point? Because you obviously don't have to inherit from it, but it's about encouraging good behavior, not just dictating it.
Exactly.